Hello, everybody. I hope you're all going well at this virtual conference. Today we're talking about PatchBot, which is my software system. My name is Tony Williams, and I'd like to talk about application packaging and patching with my system, as I said, called PatchBot. So what's the problem I'm trying to address? If you have a well set up MDM, then for me, the biggest challenge was keeping all the packages up to date in Jamf Pro and the fleet properly patched. In a high security environment, such as a finance company like Suncorp, it's not only challenging, but vital. So what's the solution? Well, it's a lot of manual work or some automation. At Suncorp, I've leveraged AutoPkg, the patch management system in Jamf Pro, and the Jamf Pro API to build an automated solution where most applications are patched on my fleet without me touching a thing. Patch levels across the fleet have gone from woeful to good in a period of 6 months. Today, I'll cover how the system works and how it's put together. Along the way, I'll cover the advantages of leveraging patch management and how that informed PatchBot's design. What's the end result? We want to end up with a complete software system that automatically builds application packages when a new version is available, uploads them to our Jamf Pro instance, makes them available for testing, and finally moves them into production without any human intervention, informing us of its progress along the way. How is it built? What are the key components of the system? AutoPkg is the core of it all. While AutoPkg builds packages, it can do much more. If we consider that AutoPkg is a process that reads a recipe and runs the steps in the recipe, with each step performed by what it calls a processor. In fact, this is a semi-independent Python script. You may already be using JSS importer or Monkey integration to allow you to do more using custom processes. PatchBot uses 3 custom processes tightly integrated with Jamf Pro. The Jamf Pro API is the second part of our puzzle. All 3 custom processes, written like AutoPkg in Python, use the API. I use the classic API throughout, as the new Jamf Pro API does not have enough coverage of the parts of the system we want. The absolutely vital key to leveraging patch management in Jamf is to have a high-quality, reliable patch source for your new patch definitions. The patch definitions you get for each application is essentially a version and a release date. I buy my patch source from Mondada as a Kenobi subscription. Given the quality and the convenience, the cost is quite small. They have been swift to add to the application coverage when I start building a new package, and also to fix the rare problems. Kenobi have a public domain version of their server software if you want to do it yourself, and there is a community that offers the required definitions. I cannot stress enough how critical a good patch source is. And of course, that patch source feeds into the Jamf Pro patch management system. Crucial to an easy workflow is the patch management system in Jamf Pro. I've heard other Mac admins mutter about patch management's usability, complaining about its so-called lack of coverage. But I think it's great once you've got a good patch source. The one Jamf provides is okay for testing, but does indeed lack coverage. In production, a better patch source makes patch management a key tool. It works incredibly well. Then there's the bit I'm proudest of. I've written 3 custom AutoPkg processes and 4 helper scripts for a little more than 1,200 lines of Python code. I'll go over all these scripts in the next few moments. Just a small digression. A quick word about scope. One of the nice things about using patch management is that patches are automatically scoped. Patches are only seen by users who have an old version of the application on their Mac. This means we only need to worry about the test patches, and there I only need one computer group for each group of testers. Since a large part of my fleet of developers, I have one group for developer package testing and another for the more general apps. That's two groups to provide all the scoping I need for over 50 applications. That makes it considerably less than the number of groups required to do the same thing with policies in JSS Importer. The package lifecycle. What happens in the system? What is the lifecycle of a new package, a new version of an application? It has three parts. First, it's uploaded to Jamf Pro. Second, it is put into testing with a test patch. Finally, a week later, it is put into production and goes out to the whole fleet. Each of those steps requires a single auto package run, and each step uses a custom processor. Each step requires a recipe. Each step uses a Python script to massage the report from auto package and send it as a message or two to teams. Let's have a closer look. The first stage is, of course, to build the package. In the same step, is uploaded to Jamf Pro using the first custom processor, JPC Importer. This is the auto package command we run. It's the first command in a daily shell script. I wanted to show this to you so I could mention some useful features of auto package and how I use them. The first thing you'll notice is that I specify a text file, packages.txt, as a recipe list. Auto package allows me to do this rather than list all the recipes on the command line. I do this so I can have this command in a shell script and never change the command. All I do is add and subtract recipes from that file. Second, you can see I'm running my custom processor, JPC Importer, as a post processor. This means that after auto package has completed the package building recipe for an application, it then runs JPC Importer without having to change or override the standard package recipe. Notice the com.patchbot on that second line. That tells auto package where to find the processor. Third, you can see I'm specifying a plist file as a report. Auto package will, when requested, write out the results of a run into a well-structured plist file. It's this I'm reading to decide what messages to send to teams. Finally, you can see I'm setting a variable, fail recipes without trust info. This makes use of a security aspect of auto package. It allows you to create a recipe override, which is another form of recipe, and overrides contain a hash of all appearance recipes in the override. This is the so-called trust information. So this option tells auto package to not only fail if the hash in the override is wrong, but also fail if the override is missing. This makes sure that nobody is fiddling with our recipes or the recipe list. So what exactly does JPC Importer do? Well, as the name implies, the first thing it does is import the package that has just been built into Jamf Pro Cloud. It does this by uploading the package and then updating the package category and adding a description that says it was built by auto package and the date it was built. It also points a test policy, not a patch policy, but a regular policy, at the new package. This policy is disabled in scope of nobody. Its sole purpose is to serve as a database record that holds the package details for the next stage of the process. Before we progress, let me have a short rant. Uploading packages to Jamf Pro Cloud in a script is difficult. Jamf do not provide a supported API method. There are currently 3 different Python methods in the wild. The one I use, which uses curl, the method used by Graham Pugh in his upload processor that uses the same endpoint, but the requests module in Python. And finally, there is Mosen's method used in JSS Importer that attempts to mimic the web GUI method using requests. All three methods are a hack. All three had problems. All three lack a method of updating the package details at the same time as the upload. All three sometimes fail for reasons known only to God. We do know that the larger the package, the more likely it is to fail. We also know that even uploading large packages via the web GUI can sometimes fail. For me, the tipping point seems about 2 gigabytes. Over that, I start having problems. We also know that a good method must be possible, because even though Jamf don't have a reliable method through the GUI, the Jamf admin application seems not to suffer from the same problems. The biggest problem facing anyone trying to automate Jamf Pro Cloud is this API. It's well past time this was fixed. Okay, rant over. Back to the process. We haven't quite finished stage one. We still need PatchBot to tell people what it has done. This is the next line in my shell script. The Python script teams.py reads the plist file from the AutoPkg run and sends the messages to Teams. Here's an example of what one of those messages looks like. The policy button opens up the policy in Jamf Pro. I don't have a reason for doing that anymore. It's just a holdover from an earlier version. I haven't thought of any other use for the button, so I've just left it there. This is a Teams message telling me that AutoPkg had errors. The top one tells me that I don't have an override for that recipe. Remember that fail recipes without trust info option? Having that set made this pop up. I actually added that to my recipe list just to generate the error. The next tells me that DAP notify recipe is having problems. The error tells me which part of the recipe has failed, but isn't terribly informative without some digging. With this one, it turns out the author changed how he packaged DAP notify, so the recipe broke. Luckily, the recipe author kept it up to date, and all I needed to do was to get AutoPkg to update the recipe. If there's an error similar to this, that's always a good first step. The second stage is to update our test patch policy to use the newly uploaded package in another AutoPkg run. I do this in the second half of the shell script. You can see that it is almost identical to the first half, except for the name of the recipe list is patch.txt instead of packages.txt, and it uses a different script to send messages to Teams. This uses a second custom processor, patchmanager.py. It not only gets our test patch policy using the right package and enables it, it also writes a self-service description. This processor doesn't run as a post processor, but requires a recipe of its own. This is what a patch manager recipe looks like. It's incredibly simple, really. It specifies the processor at the bottom and the two arguments. At the moment, both arguments are required, even though they're often the same. I should fix this. And in fact, I may well have done it by the time you actually see this. If you have a look at the bottom where the processor is defined, you once again see com.honest.patchbot. This is because all three custom processors are saved in one particular spot. So what exactly does Patch Manager do? The first thing it does is grab that test policy we updated in JPC importer to find out the version number of the latest release. Then it has a look at the patch software title record in Jamf Pro to find the patch definition for that version, and if it doesn't already, points it at the package. Then it updates the test patch policy to the new version, writes a self-service description, enables the policy, and we are done. You might wonder why I wanted to show you a self-service description. It's because it's this self-service description that starts the clock for when we move the package into production. You can see it contains the date. Oh, and look, I totally sidestepped the argument about whether they should be English dates or US dates. I use ISO 8601 format dates. That's obviously the 20th of July 2020, and I like it for no other reason than it sorts properly. I have a self-service deadline for 3 days for the test patch to make sure I get timely screens if the package is broken, but that's set ahead of time when I create the patch policy. You may notice that unlike JS's importer, PatchBot doesn't create groups, doesn't create policies, and doesn't worry about scoping. You have to do all that by hand. There are 2 reasons for that. One is that it reduces the complexity of the task, and that reduces the places where things can go wrong. The second is that PatchBot can run using an account with far fewer privileges for a much more secure system. You only have to do these tasks once when you add a new package. It's not terribly onerous. Here's the Teams message telling us packages are now in testing. This can be sent to a more public Teams channel that includes my team and all the testers. Here's one telling me of errors. In this case, the error is not in the software. Sometimes you can find that you've downloaded a new package before your patch source has given you a patch definition for it. Now, obviously, we can't point a missing patch definition at our package, so we have to wait. This timing problem usually resolves itself by the next morning. But if it doesn't, there may be a problem in your patch source. This has happened to me once so far. Of course, these messages are sent to my Teams channel and not to testers. A quick word about names. Another short digression. Gee, I guess it's starting to become a habit. This time I'd like to talk about names. Earlier in the design process for PatchBot, I realized something about names in Jamf Pro. The name of objects, such as packages, policies, and patch definitions, are never seen by the end user. The name they see is set in the self-service section of the object record. This means that the names can be entirely for our purpose, in this case, to help automate the system. So, I have incredibly tight naming conventions in my Jamf Pro instance, and PatchBot is designed to rely on these conventions. These are typical of the rules I've used. Stage 3 is moving a package into production after a week. The key to this is a Python script, move.py, that decides when we should run the process to move a package into production. Move.py at its core is a loop that runs through the patch policy list. If the policy doesn't have test in the name or it isn't enabled, it's ignored. If it is, then I grab the patch policy self-service description and look at the date, compare it with now, and if it's more than a week ago, I add the application to a list. When I've finished the loop and the list is finished, it's used to construct an AutoPkg command similar to the 2 previous commands, except it has a third custom processor, production. This custom processor points the production patch policy and the application install package at the tested package and disables the test patch policy so the system knows the process is complete. This custom processor also requires its own set of recipes. Then finally, it calls a third Teams script, prodteams.py, to send messages to Teams. We are now at the end of the process. Before we move on, let me explain the design decisions around splitting the logic for when to go into production out of the custom processor and into a script of its own. What we have explored is perhaps the platonic ideal of workflows. Imagine, though, a couple of different scenarios. First, imagine if you'd moved a package into testing and a tester claims to have discovered a serious bug. You want to stop that from going out to production until it's checked out. With the way we've built our workflow, all you need to do is to go into Jamf Pro and remove the self-service description on the test patch policy. Now, the workflow into production will never trigger, and if you discover the tester is wrong, you can always put the date back in and it will flow through production. That's one reason for having the logic in move.py rather than the processor. The second scenario is even more critical. Imagine Google discovers a security flaw in Chrome and releases a patched version. You want to get that new version tested and into production as fast as possible. With the current design, there's nothing stopping you from running the production recipe manually well before the 7 days are up. Then it goes into production that much faster. That's the second reason for not putting the decision logic in the processor. That's the end of our life cycle. Now, to finish the presentation with a look at the final pieces of the system. Before we finish, allow me to add a little bit of the plumbing behind PatchBot. PatchBot is run by one shell script and the Python script move.py. But how do we get them to run? For this, I have two launch agents. The only complication is that one launch agent runs packaging and patch management early in the morning every day. I only run move.py Monday through Thursday to maximize the chance that if a user runs into a problem with a newly installed patch, they're likely to find somebody who can help on the service desk, which wouldn't happen on the weekend. The next thing I'd like to stress is version control. By the time you finish setting up PatchBot or similar, you'll have a whole bunch of patch manager recipes and production recipes before you even start into your own packaging recipes. This represents a lot of work, so I have separate Git repositories for each sort of recipe. If your organization doesn't have an internal equivalent to GitHub, then perhaps use private repos on GitHub or somewhere equivalent, but do use it and do learn how to use Git effectively. I've learned a great deal in the last 3 years about Git, and it has saved me more than once. Finally, I can be found on the Mac admin's Slack as Tony.Williams, usually in the ANZ channel. I have a GitHub repo that includes all the code that I've discussed today, and there are 5 articles also discussing PatchBot on my blog at that address, and if you really wish to contact me, you can mail me at tonyw@honestputt.com. Thank you for listening. There should be a survey below me that has a survey widget so you can give some feedback. Thank you very much, and good day.